Okay, let's go ahead and solve for the transfer function in the frequency domain h of omega of this circuit. And what we want to notice is that the resistor comes before the inductor in this series type configuration. And essentially, we want to prove that this circuit is a high pass filter. And what we're going to use is something called nodal analysis, where we're going to pick a node right here and solve for the currents leaving it. So the currents going in this direction plus the current going in this direction has to equate to 0. So I'm going to say then that V out of omega in the frequency domain minus V in of omega over R plus V out of omega minus 0 over J omega L has to equate to 0. So then I get that V out of omega, I can pull out a 1 over R plus 1 over J omega L has to equate to V in of omega over R. So then V out of omega times J omega L plus R over J omega L times R is equated to this V in of omega over R. So then my final result, H of omega, which again is equated to V out of omega over V in of omega, has to be equated to J omega L over J omega L plus R. And essentially, if we see the magnitude response of this circuit in respect to omega, if we plug in omega here, we simply get 0. And as we increase omega to infinity, we get 1. So my magnitude response will look something like that as omega goes to infinity. Thank you.